In this video, I would like to demonstrate how to draw a flange coupling, and since I cannot upload long videos, I'd like to demonstrate how to draw a flange alone in this video. So starting off, create a new project, part in solid, deselect use default template so that you can change the units. So I'm going for MMNS, part solid. Okay. So before drawing, I have a reference for the flange. I have a diagram, and usually the flange coupling looks like this. This is used for transmitting power and motion. There are two flanges which are fixed by a bolt nut, actually four pairs, and these two shafts are the transmission used for transmission of motion and power. And for rigidity in shaft, we use a keyway, and we place a key in the keyway so that it's not free to move. And instead of tap a key, we use flat key in this drawing, because tap a key would be a bit more complicated, and we'd see it in later stages. So let's come to the protected. We're actually drawing a protected type flange coupling, because in unprotected we don't have this extrusion, so it doesn't make a big difference. We'll see this, and then later on we'll move on to the other unprotected type too. So to draw a flange, let's go for flange number 1. To draw a flange, this is the diagram for it, and I'm using these dimensions for reference. This flange, how would you start? That's the main problem for most of us, because once you get to know how to start a diagram, it's easier later on. So for me, I feel the best way would be, because since it's a circular object, it would be better to revolve around 360 degrees. So this is the reference line as they have given, and there's a solid body here. So draw the top half of the body and then revolve it around the same axis, so it gives you this circle. So before starting the diagram, properly read the dimensions and understand the diagram clearly. If not, the complete diagram would go waste, because during the assembly it would not made properly. Let's draw the rough sketch of this top half. Choose any of the planes and give sketch, and then just draw a rough sketch. It's all just simple. Do not give these constraints, because it won't let you give dimensions to every single line. So just move a bit away from the constraint. Yeah, this is how it would look approximately. So read the dimensions. So how much is this distance actually in the diagram? So this distance, just till the bottom of the keyway. So this whole thing is 53.4, but including this, it would be, this is the diagram for the key, so the height of the key is given as 10. So you'll have to minus the length from this total length. So it would be like 53.4 divided by 2 and subtract 10 from that. So 53.4. So that will be around 16.7. So this is 26.7. This whole thing is 26.7, and this thing is 10. So this thing should be 16.7. So change the dimension just by double clicking it. 16.7. And then what more dimensions can we give? Yeah, this thing is given. It's 75 minus 53.4 would give the total length of this and this. So dividing it by 2 would give one part of it. So 75 minus 53.4 divided by 2, it's 10.8. It's really small. And the other part of it is this edge. It's given us 5. This part is given us 5. It's smaller than that. And the height of this part, it's 75, and this whole thing is 216. So 216 minus 75 by 2 would be this whole height. I'm sorry, this whole height from this point to this point. So given this point to this point, so it's 216 minus 75 by 2. It's 17. I'm sorry. It's 70.5. I'm sorry. $70.5. Okay, so this is 16.7, and we'll have to adjust this height so that it comes back about the axis. So what is this total length? This total length is given as 46, the top part of it, because it goes along this way. This total thing is 46. So this total thing is 46, and I have to reduce all these dimensions now. And this is 97. So this part of it, how long is this? 46 minus 25 would be 21. So now the only problem is the height of this line. If we reduce that, this thing will come back to the top, and also the height of this. The height of this part can be estimated by this circle, because the total length is given as 216 and the inner diameter is given as 200. So 216 minus 200 is 16, and if you divide it by 2, because we are drawing only the top half, it's 8. So this height is 8. It's again back to normal, and this height is now, the height of this line is what we need to know now. And this point to this point. Till this point it's 50, so we'll give dimension to that first, or just wait, let's this point, it's 50 from this point to this point, so length of this is okay. So this part is 25, so 80 minus 25 would be 55. So this length, it's 55. Now remaining is this part of the length. So this height would be 75, right? Yeah, that's 75. And this total, this height would be 20 or 108. 108 minus 50, so that's 58. So this is how the final object would look like, and if you give a tick mark, it would look like this, the final position. So now we are not actually completed, so go to sketch and edit definition. You'll go back into the sketch. So now we need a reference axis, so choose this point and place the reference axis. So we're gonna revolve it along this axis so it comes round. So check this and come out of the drawing. So now use the revolve tool. We've got the flange, but it's still incomplete, but this is how it should look like. Alright, now let's provide some chamfering, which is given here, 2 into 45. This dimension shows that it's chamfered 2 into 45. So all the sides where it's chamfered is this top, this edge, and the inner edge. So there are 3 faces where it's chamfered. So choose the chamfering tool and select this part. Oops. So select this part, give chamfering, and because it's given 2 into 45 degrees, so go D into angle, and angle is given 45, and give the length 2. So it's chamfered. You can have a look that would look like this. So the other end would be this, and the other half chamfering, go for angle into D, the same thing, and then tick this, and this side too, these edges, chamfer for angle into D, and finish it. Yeah, now it's done. Now for the keyway, we need to provide this keyway. So since the height of the key is given as 10, we'll give the keyway of 5 here and 5 on the shaft. That would be actually compensate the height equally. So the keyway's height should be 5 and the width should be 16, and it should be from this circle. So that would be like from this inner circle. So choose a wireframe and then choose choose this plane, sketch on it, and then go wireframe, and then let's set a reference for this inner circle. So now we need a keyway, so choose line, and since we have set the reference, we get this marking over the circle. If not set for reference, you don't get the exact location. It doesn't get locked. Now if you move along, it gets locked. So just draw a rectangle. Just don't give any constraints, or since it's a rectangle, you can give constraints to 2 of those sides and then finish it. So now this length has to be 16 and this length has to be 5. So now come out of the sketch and then go for extrude, because we are gonna remove material, and then turn the direction and then pass it through the complete body and select this remove material option so that it removes material, and just do this and you get the keyway. So now we need to provide drilled holes for the nut and bolt. So let's sketch on this side. This is the most easiest part for a flange. Just draw a circle, then come out, and its diameter is given as 16. Its diameter is given as 16, so change it to 16, and the height from the center, it's given as this part is 150 by 2, it's 75. So this is aligned, so come out of the command and repeat the same thing, extrude. Right, extrude and select this object, remove it through the hole, remove material, and then just tick. It's done. So now we need 4 holes along all the axes. So for that, let's just select this, go for pattern, so that we can revolve it around all the other axes. So choose axis, and choose any of those axes. 4 and 2, 4 you need, and 90 degree, every 90 degree you get 1. So just give tick and it's done. This is how the flange is made.